we move to the next exercise. And yes, our third exercise is this: rearranging the following data in ascending order. So since we're still working with positive numbers only, we should still use the 2, or we can still use the 2 steps I introduced in the previous 2 slides in this case. So our first step is to count the number of digits, and in 3a we can see that all the numbers are 4 digits, have 4 digits. So we move to number 2. Number 2, we compare the first digit, 4, 2, 8, 7. Because all the numbers are different, we don't need to check the other numbers. We don't need to check the following numbers. Let me make a quick example. So we have 23 and we have 41, right? Because they are both 2 digits long, right? 23 and 41 both have 2 digits. That means we are now going to follow number 2, and number 2 says check for the first number, which is a 2 and a 4. We already know that 4 is greater than 2. That means this number is greater. So once the numbers have the same number of digits and the first digits are different, like 3a, 4, 2, 8 and 7, we can make our own conclusion and reorder our numbers just by looking at the first digit. So in this case we do the following. So 2, in this case 2 is the smallest, so that's number 1, and 4 is our second smallest number, so that's on number 2, followed by 7, that's on number 3, and number 4. So this is how you'd order this set of numbers that you'd be given, and you just need to write it down neatly. 2,674 would be first, and 8,617 would be the last number. 3b, we count the number of digits again. So 5, 5, 5, and 5. So we move to the second step. The second step is look at the numbers. So 1, 1, 1, 1, 6, 6, 6, and 6, 6, and 6, and 4, and 4. So we can see that these ones are the smaller numbers because 4 and 6. 4 is the smaller one. Between 4 and 6, 4 is the smaller number. So we have to decide which one is smaller here. And the bigger one in this range here between the two numbers would be the second number. So 16, 4, we continue 1, 6. We can see that this number is greater than this number here. So this is our first number in this sequence, and this one is our second number. Then we move back to these ones because these ones were bigger than these two on our right. So we carry on 4 and 1. 4 is greater than this one, so this one would be our number 3. The one that's smaller would be our number 3, and the first one would be our number 4. And so we move to 3C. 3C have quite a number of numbers. And this is what we see every day, which should be very easy to order. So we just look at it, and the 1-digit numbers are obviously the smaller ones. So 6 is 1, second small one is 8, then 11, and after 11 is 20. So that's a 4, 5, 20, 6, 7, 8, 9, 10, 11, 12, and 13. And so this is how you'd order it. I just use the following principles: 1-digit numbers versus 2-digit numbers. 1-digit numbers are obviously smaller, and in this case we had a repeating number, which was 43 and 43. Since there are still 2 numbers in the set, they still get a number each, so we don't just cancel the one and remain with the one. We still put it in and it gets its own number. And yes, so I basically went from 1 unit numbers and then I went to the 20s. After looking in my data set, I found out that we had no 20s anymore. Then I moved to 30s, 40s, 50s, up until I got to 90s, which is 99, which is our largest number. So we moved to D. In D, I just wanted it to be more interesting and just see what happens when we have negative numbers. And we definitely can't use the 2 rules I gave you earlier, so we do it differently this time around. So when a negative number, when there's a negative number, the larger it is, the smaller it is. So between 98 and 99, 98 is smaller because it's in the negatives, because our number line goes from 0. There's 0 here, so it goes up until 100. We pass 100. 1000 is this side, 1 million, and we keep going. This side we also have negative numbers, so there is still a number line on the left side of the 0, but all the numbers are negatives. And as you can see, that 100 is this side of the number line and negative 100 is this side of the number line. That means as we go to negative 1 million this side, it's getting smaller and smaller and smaller and smaller, and when we go this side, it's getting bigger and bigger and bigger and bigger. So that's how we do our exercise number 3. Let's see if we have another exercise. I think this one is our last exercise. Exercise number 4. Rearrange in descending order. Descending order would just mean from the largest number to the smallest number. So let's look at our data. 4a. We can see, just by looking at it, we can see that 77 is our smallest number, so we put it at the end already. So there it is. So it's already out. So we have 4 numbers left, and since they're positive numbers, we can still use the 2 instructions I gave you in the previous slides. So we look at the first digit, 9, 2, and 2. We can immediately see that these 2 are smaller than these 2 numbers. So let's deal with these ones and just plug them there. So 2 and 2, 1 and 9. We can see that this number is greater than this number. That means this number is smaller, so we put it there, 2, 1, 9. And this one comes here, 93. Then we are left with these 2 numbers. So it's a 9 and a 9, 1 and 2, 3 and 2. 3 is bigger than 2. So our largest number is this one, 913, 913. So we put it first, and then this one comes down there. And that's how you'd order your numbers in descending order. So let's do the next. 4b. 4b, we can see that all the numbers have the same number of digits, so we move to number 2. Number 2, I'm just going to clear up that so that we can see our numbers for 4B clearly. So descending order, we start with the biggest one and we go to the smallest one. So the easiest thing is to look for the smaller numbers. In this case, these two are our smaller numbers because 6, 6, and then we have 7 and 7, which makes these two numbers bigger than those numbers, right? So after we have established that, we get our smaller number. In this case, it's a 6, 7, and a 6. So this is our smaller number. We put it at the end. 6, 6, 7, 7. And this is our second smaller number. 6, 7, 6, 7. 6,767. And then we are now left with these two bigger numbers. So 7, 7, 6, and a 7. 6 is smaller than 7, which makes this number bigger, so it goes right there. This is the bigger number because descending order is from large to small, just like that. And then for C, all our numbers have the same length, so we move to number 2. 1, 1, 1, 1. Okay, great. Move to the second number. 4, 4, 5, 5. We can see that these numbers are smaller and therefore they should go right at the end because descending order is from large to small. So which one is our smaller number? Which one should go right at the end between the two? So 1, 1, 4, 4, 2, and 1. 2 is greater than 1. So this number is the smaller one. So 1, 4, 1, 0, 2. And this one goes right next to it. And between these two numbers, 1, 1, 5, 5, 1, 1, 1, 2. 1 is smaller than 2. So this one is our bigger number. It goes right in the beginning. And this one just falls in between. D, how to do D? D, all our numbers have the same number of digits. So we move on to step number 2, 7, 7, 7, 7. Great. Next number 6, 8. Okay, 6, 6. From looking at this, we can see that 8 is the bigger one. 8 is bigger than all the 6s, so this one is the first number. 7, 8, 7, 3, 1. And so we rule it out. So we have 7, 6, 7, 6, 7, 6. The third number is 3, 1, and 3. So this one is the smallest number. This one is the smallest number, so it goes right at the end. Because 3 is greater than 1, and this 3 here is greater than that 1 also. And then now we have two numbers left, and we just need to compare between the two to see which one goes where. So we have a 7, a 7, a 6, a 6, a 1. No, we're not comparing these two numbers, we're comparing this one. Okay, let's just clear that out. So we are ready to And yes guys, that brings us to the end of our video. In our next video we will be talking about how to determine the mode, mean, median, range and so forth. So see you in my next video. Thank you.